Good morning, class. We're going to start by talking about graphing linear inequalities. A linear inequality would be an equation where you can have one side different than the other when you simplify it. In this case, we're going to graph them, and if you recognize this is the slope-intercept form, y equals mx plus b, the y-intercept, the slope, and this is going to talk about shading and the type of line we're going to draw. We're going to start off by just basically graphing, as we do with slope-intercept equations. We're going to start off by graphing the y-intercept. So it's a positive 1. So our first dot is going to be on positive 1. Comes right here from the y-intercept. Then from this point, we are going to follow the slope. It's a slope of 2, which means it has a rise of 2 and a run of 1. So we're going to start here, rise of 2, 1, 2, and a run of 1 in a positive direction. There's my next point. You could continue that pattern in the positive direction, but remember, you can also graph backwards by changing the signs of each of the numbers and graph down 2 and to the left 1, down 2 and to the left 1. And that's going to give us a line of dots. From our inequality symbol, we're going to decide whether we're going to draw a solid line or a dashed line. A solid line would be given when there's an equal sign. You need an equal sign in your inequality to get a solid line. You get a dashed line when there is no equal sign. So since there is no equal sign, our inequality line is going to get a dashed line, which means nothing on that line would be a solution that we can use. So in that case, you're going to get a solid line. Go through the lines, arrows at both ends. The inequality itself says that we are going to shade below the line. A less than symbol shades below the line. A greater than symbol shades above the line. So this is for our shading. Okay, so here we are. We are a less than symbol, so it's going to shade below the line. So anything below the line, if I was to turn this to my body, remember it goes down towards you. So anything in this area is going to be a point that we can use that would make our inequality true. We just shade right in this area right here. And I'm going to use this highlighter to indicate the area we're shading in right here. Everything in this point right here is a solution to our equation. We can check that by testing it out. We can pick a point anywhere in here and say, hey, does these numbers, 3 for x, negative 2 for y, make the inequation true? Let's find that out. X is 3, y is negative 2. So I'm going to put a negative 2 is less than 2 times 3 plus 1. Negative 2 is less than 6 plus 1, which is 7. Is negative 2 less than 7? Yes, it is. So the points in this side work. The points in this side will not. If I pick that point right there, a negative 4 and a positive 3, you can say over here, you can say 3 is less than 2 times negative 4 plus 1. 3 is less than negative 8 plus 1. 3 is less than negative 7, which is not true. Negative 7 is a smaller number. So this is not true, and the points on this side of the graph do not work. If you were to pick points on the line itself, both sides would be equal. And since there's no equal sign here, we cannot have that. So we can't include anything on the line. We can include things below the line, but not on it or above it. There you go. That's how you graph a linear inequality. Let's go ahead and do this one. I'm going to say that we've got this equation, y is greater than or equal to 2x minus 2. It starts at negative 2. And stop the video and go ahead and finish graphing from that point. With a slope of 2, 1, 2, and a positive 1, there's my next point, 1, 2, positive 1, and you can go backwards, negative 2, negative 1, negative 2, negative 1. And we're going to graph this line with a solid line this time because there is an equal sign. There's an equal sign here. So there is a solid line. So things on the line can be used because we can have both sides equal. Arrows at both ends. Don't forget that. And then we're going to shade things that are above the line because my greater than symbol says we're going to shade above the line, and this would be above the line, and we're going to shade in this area. Here we go. Just trying to be a little neat, as we always should, and things in this area. If we were to check a point out in this area, we would find that the y value would be greater than what I do to the x value on this side. Let's test that out. I'm going to pick this point 3 comma negative 3. Y is 3, has to be greater than or equal to 2 times negative 3 minus 2. 3 has to be greater than or equal to negative 6 minus 2, which is negative 8. Is 3 bigger than or equal to negative 8? Yes, it's bigger than. It could even be equal to, it could be bigger than, but it can never be smaller than. So this is true. The point in here works. The points over here will not work. And I can choose things on this line because the solid line means I can use them. The dashed lines means I cannot. All right, guys, go ahead and take care of your classwork and make sure that you can review back to this video to see if you need to understand anything. Have a great day.